The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Hi, and welcome back to the Learning Circuit. Today, we're going to learn how to drive a 7-segment display using a BCD to 7-segment decoder. This is a 7-segment display. You may have seen one in an alarm clock, a radio, or some other piece of technology that's been around for a while that needs to display numbers. 7-segment displays contain LEDs that light up 7 individual segments. Numbers can be displayed by changing which segments are on and which are off. Each LED lit segment is controlled by a separate pin. You may notice this display has an extra 8th pin, labeled DP, that controls the decimal point. In this display, all the anodes are connected together, making this a common-anode display. There are also common-cathode 7-segment displays where the LEDs are flipped, with the cathodes all connected and the anodes going to the individual segment pins. I chose to use a common-anode 7-segment display, so I'm using a 74LS47 decoder as a driver. In the last episode, we discussed how BCD is converted to 7-segment. BCD is binary coded decimal, a 4-digit version of binary. So this type of decoder translates 4-digit binary to 7 signals that control the LED segments of the display. So if we want to display a 2, we input a 4-digit binary 2 into the decoder, and it outputs signals that turn on the appropriate segments to display a 2. If you want to try to understand how the decoder works more in depth, take a look at the datasheet and try to decipher the logic diagram. It's pretty complex, so I'm not going to take the time to get into it right now. So we know our chip needs at least 4 signal inputs, the 4-digit BCD number, and at least 7 outputs, one for each of the LED lit segments. Let's take a look at the pinout for our decoder to find them. Our chip has 16 pins. We're used to seeing VCC, our supply voltage, and ground. On the left, you can see pins 7, 1, 2, and 6 are labeled A, B, C, and D. Those are for the BCD input, 1 pin for each of the 4 digits. On the right, you can see that pins 9 through 15 are labeled lowercase a through G. These are the 7 outputs, 1 for each segment of our display. We'll get into pins 3, 4, and 5 later. For our circuit, we'll use 4 switches to manually input the BCD number. If we look at the function table for our decoder, we can see that the inputs need to go high to send a signal. You can see that when A is high and B, C, and D are low, it sends a decimal number 1. So we want the supply voltage going through our switches to those input pins. For funsies, we'll add an LED to each switch as an indicator light so we know when it's on and to help visualize our BCD numbers. And we'll be sure to throw in some current limiting resistors to keep our LEDs happy. The LED anodes connect to the supply voltage through the switches and to ground through the resistors. We'll connect each switch LED combo up to the correct input pin on the decoder, A, B, C, D, going right to left so we can input our BCD numbers. On the output side of our decoder, we'll need each of the 7 segment pins to connect to the corresponding pin on the display. As we know, our display is made with LEDs, so once again, we'll add current limiting resistors, 1 for each LED lit segment. Okay, our main signal inputs and outputs are taken care of. Let's take a look at the rest of the pins to see what we still need to do. Our display still has 3 pins open, 3, 5, and 8. This display has an extra LED for the decimal place, pin 5. You don't ever want to leave pins floating, meaning unconnected, so we'll connect it to ground so it's always on. And since it's also an LED, we'll use another current limiting resistor. We're using a common-anode display, and as usual, anodes are connected to power positive. So pins 3 and 8 need to be connected to the supply voltage. Okay, that's it for our display. Now back to our decoder. Pin 16 is VCC, so we'll connect that to positive on our power supply. And pin 8 is ground, so we'll connect that to ground. That leaves pins 3, 4, and 5. Pin 3, LT, is a lamp or light test. It lets you test the display. If this pin is low, all segment LEDs will turn on. Pin 5 is a ripple blinking input. If this pin, plus the 4 inputs are low while LT is high, all segments are off. Pin 4 has 2 functions. The first, blinking input, is active low. So when this pin is low, all segments are off, no matter the status of the inputs. The second function, ripple blinking output, is to provide a low level if inputs A through D and RBI are at low level while LT is at high level. All of these pins are active low, so we want to pull them high to keep them inactive. So we'll connect them to the supply voltage using a 1 kilo ohm resistor. Okay, that's everything. Let's put this thing together. Electronics, assemble! Now, more commonly with this circuit, you would probably use a microcontroller to send your input signals in place of the 4 switches. Now, I did this project to show how a decoder works, because in the last episode, I talked about multiplexers, demultiplexers, encoders, and decoders. Now, if you've got a project that incorporates one of those 4 ICs, I would love to see it. Please post about them on the Element 14 community on element14.com/the learning circuit. And happy learning!